Guys, welcome back to my math YouTube channel. So far we have covered different variety of evaluating or computing the derivative of different functions. We use the product rule, the power rule, the quotient rule, and the chain rule, and we also use like a combination of many different rules as well. So guys, now I want to talk about some basic functions like the log functions and the exponential functions. They're not too complicated. Here again guys, I'm not really deriving or showing you the whole proof or derivation of how to evaluate the derivative of an of a log function. Exponential function we might actually see because there's an easier way of actually evaluating that. Guys, I highly encourage you to go back and look at your textbooks and see how we use the limit definition, because it's not like a very complicated way of deriving the things. It is you just have to go through the steps and look at the steps carefully. Guys, please do that. See how we get the derivative, how we derive the derivative of log function, or even for that matter, how do we derive the derivative of an exponential function using the limit definition. Here guys, I'm just going to write the actual derivative of those functions, and then we are going to try to see many different variety of examples. Guys, in the log functions and the exponential functions, one also has to kind of review the basic properties of logs and basic properties of exponential functions. Here I'm going to remind you some of the basic properties. Guys, for the logs we have three basic properties that I'm going to list here. First one is called the product property. So it's if you have log m plus log n, and then that is equal to the log of the product m times n. And it can be natural log or log to the base 10. Let's see, I'm using here log to the base 10. It can be natural log as well. So the other one could be log m minus ln of n. So where this is like a natural log, and it is equal to the log of m over n. That is called the quotient, right? And the third one, which is equally important, is if we have ln m to the power n. So where we have it's called the power rule, power property for the logs when we have m to the power n. So what happens, you just bring that n up front and it's n times the ln of m. So guys, these are the three basic properties that one has to remind themselves, or one has to know before one starts actually finding the derivative of the log functions. Okay, so keeping those in mind, let us now write the general form or general definition for the derivative of the log functions. So guys, let us first start with writing the d over dx of a log function of the form log x to the base b. So this b can be, it can be 10, it can be a natural base which is e, or any other number. Okay, so the derivative of that function, again, which is something that you can see from using the limit definition, and I'm not really deriving the whole thing, I'm just writing the final form. So guys, this is equal to 1 over x. That means it is equal to the inverse function. 1 over x is the inverse function, but you also have to multiply the denominator by the ln of b, which is the natural logarithm of this base b. Guys, this is the definition, or this is the formula for finding the derivative of the log function to any base b. What is it? It's 1 over x, whatever this x is, 1 over x, whatever the quantity we have here, and then it's the denominator has to be multiplied by the ln of the base. Okay, so guys, based on this, the very first consequence of this that we need to know or we need to write is, then what would be the derivative of just a natural log of x? So to find the derivative of natural log of x, again, we can use the same formula. It's going to be 1 over x, but we got to multiply by the natural log of base. And in this case, we already know that the base is e, so it is ln of e. But guys, we know that the ln of e is just 1. So the final answer is just going to be 1 over x. So if we have to find the derivative of the natural log, it is just simply 1 over x. Similarly, guys, the third thing that I want to write here before we start actually doing examples is something which requires the idea of a chain rule. So for example, if we have to write the derivative of ln of u, where u in turn is a function of x, so it's like a composition of functions. So guys, in this case, again, we got to treat this guy as just the log ln of x. So what is the derivative of ln of x? It is just 1 over x, but we don't have an x here, I have a u here. Right, guys, this is how we actually apply, or this is my way of actually applying the chain rule. It just makes life a little more easier for us. And then, but we cannot stop right here. We still have to multiply by the, so we're just following this definition, 1 over x, inverse function, 1 over u. But then u is also in turn a function of x. So in order to take care of that, one has to multiply, and that's we are basically using the chain rule. You have to multiply by what? You have to multiply by the derivative of the inner, and in this case, the derivative would be d over dx of u. So this would be the definition or formula for finding the derivative of using the chain rule process. So guys, these are the basic log properties that we need to really know, and we need, because we are going to apply them. If we don't remember these, or if we don't use them, then guys, it's going to be very complicated, and maybe sometimes it's going to be almost impossible for us to evaluate the derivative of functions that involve logarithms. Okay, so guys, these are very important because we need to really use them to actually find the derivatives, and this is the kind of stuff that we learned from algebra and pre-calc, and now it's coming back and we're just bringing everything together to finally evaluate the derivatives. In this case, it's of the log functions. Okay, so guys, please take some notes on this, and then we are in my next videos, we are going to start doing some examples. Again, I have chosen many different variety of examples, which I like to call from type 1 to type, probably I'm going to do 5 to 7 examples again on the logs only. So guys, keep watching these videos, practice these problems, and I will see you next time.